Okay, this is a Solopower individual cell. We're going to prepare it for testing. First thing we do is turn it over and attach a wire, a tab, to the back of the cell. We're going to do that by using conductive tape. Simply cut a piece of tape and attach the wire tab to the back. This becomes the electrical connection for one part of the cell. Now we have to make a connection to the second part of the cell, which is this header along the top. This is a tiny strip of material that collects the energy from the solar panel, from the solar cell. So now we have to attach another wire, another tab, to this area here. I'm going to attach it to I'm going to do the same thing I did on the back, but I'm going to do it on the front along this little strip, trying not to cover up too much of the active solar material. Now I'm going to purposely run the tape onto this backing material, which is an insulated piece of plastic, just to make the thing a little more rigid. So first thing I do is set that right where we want it.
I'll cut some pieces here.
And then we take the tape and we put the tape over the material, pressing the wire tab onto that strip that was across the top. It doesn't have to touch every bit of the top strip, but the more that it touches, the more efficient it will be at bringing the electricity from the cell to the wire tab.
I'm going to hold the tab straight.
Yeah, hold that tab straight. A little bit down. No, other way, other way. Right there. And you just pull that apart so we get the sticky back on it.
Go.
Okay, pushing this metal tab down against the material on the solar panel assures that you make good contact. The conductive tape additionally helps make contact. Now we have the solar cell ready for testing. We've got a wire on the back, which is a tab here, and we've got a wire on the front, which is a second tab. This is our tester. These meters show voltage and amps connected to the cell. connecting one wire to there, one tab, and then the other tab. The voltage is 0.42, but we're in the shade. We're not even in the bright sun yet. So we move the solar panel, the cell, into the bright sun, and the open circuit voltage is shown on the meter as 0.43 volts, or 534 volts, millivolts. But we like the decimal point, so that's the voltage, 0.53 volts right now in bright sun. That's open circuit voltage.
A little over half a volt.
Yes, just over a half a volt. Now the way we're going to test it for short circuit is to throw this switch, which will cause the tester to put a short circuit across this and force the cell to draw as much power as possible. Right now in this particular sun, we have some shading here. We've got up to 2.7 amps. That's the amps produced by it.
We've got shade here with the camera.
Yeah, we got a little bit of shade there, 2.8 volts. And don't forget, we are actually covering part of the cell with the conductive tape. But we're getting good sun. We're pointing it at the sun. We got 2.8, 2.75, and that's the number of amps that we're producing by connecting to the back, this one here, and the front, this one here. Turn it off the short circuit, and the current goes way down. Now we have some other resistors, but they do not produce very much of a load, so they don't add very much current to the amps. We haven't got this optimized for small cells like this. Right now we're producing 0.03 amps at 0.44 volts, but we don't have the optimum resistor to load it right now. Short circuit amps, 2.83 volt, 2.83 amps. And open circuit voltage, 0.4, 0.5, 0.5, 0.5, whatever. So you can see that when we disconnect it, it goes to 0 because we're not getting anything from the panel. This is how you can test the individual cells by hooking up a wire, in this case a tab, to the back, and another tab to the front along the little strip that has all these little fingers on it that collect the electricity from the whole cell.
Great, thanks a lot, Ron.
Okay.
Good job.
That's it.